Good evening, everyone, and welcome to the Developer User Group Meetup. Tonight, we're going to have Ewald talking about Fyne and Go, and what was that? Building a building a desktop app using a backend language, I believe. That's the title of this one. Yeah, Ewald is there goes load shedding. Sorry about that. Hopefully something comes through, but you're going to see me in the dark with my screen. There we go.
Yeah, there we go.
A little bit of light. Anyway, before we get started in this festive load shedding mood, we want to thank our sponsors. First one being JetBrains, who loves to hand us vouchers for their product. Look out for those. Keep active, and you might just get one. Tasks on Demand, that has a whole bunch of cloud solutions available. You can contact them and ask them about them, but they've been going for quite a while. Yeah, and then we've got Intellect, of course, that sponsors the Zoom room. And when these talks are in person, pizza and drinks as well. Yes, so one last thing before we get started, actually, we've got, I believe it's 14 tickets for DevConf in Cape Town left. So if you are still looking for a ticket for DevConf, convince your manager, convince yourself to go out and buy one. Those are available on web tickets. You can see some details on the DevConf website. I'll put the link down in the chat. But yeah, it will be amazing. It's on the 23rd, I believe, which is next week, Tuesday. Right, and that's about it for all of the background around everything. Ewald, take it away.
Okay, cool. Thanks, Ezra. Man, welcome, peeps. So today we're going to just take a look at a little bit of an adventure that I had. As a backend developer, I don't often get to build desktop apps. That's something I used to do in the 90s and early 2000s, and then web happened and all of that, and we just never bothered to build desktop apps that much anymore. So with that being said, what happens in 2023 if you're a backend developer and your project requires a desktop application for whatever reason? Where do you go? What do you do? How do you go about it? I mean, do you now go and grab TypeScript and grab some of the popular frameworks out there and build something that's kind of like a hybrid app? And that's definitely an option, but I looked at it and went, well, we're really using Go as a backend language. Go gives us a lot of productivity, safety, support, speed, performance, all those wonderful things that it's been designed to do. So why can't we just kind of start using that instead of switching to another language or a completely different tech stack? And then I discovered Fyne, and I started looking at Fyne, and it's an awesome UI toolkit that allows you to use your existing Go skills to build desktop applications. And what I like about it is in the more declarative style. So you can find patterns like you would use in Flutter or React or something like that. You can find those kind of patterns in Fyne as well, but with a Go flavor. So all your Go skills can be applied to do evil things like build desktop applications. In our case, most of our business logic was already built in Go, so it was nice to just port all of that to run natively on desktops. And you end up having this one binary that you can ship, and everybody just runs that, and all the dependencies and everything is in there. Mac, Windows, and Linux, which is quite a bargain. If you're interested, I did put the repo on the Meetup, so you can go find in the README. There's a link to Go and to Fyne. And then of special interest, I just want to say, if you want to learn Go, Free Codecamp recently released a really cool, I think a 7-hour-long video course on how to learn Go from scratch. It assumes that you know nothing, and then it works you through some of the most common Go paradigms. And at the end of the day, you've built a few projects, and you will definitely know Go well enough to use it in anger. So let's take a look at what we're going to do today. We're going to start by looking at the main function, which is, we know that's how Go gets into the world. And a lot of this is going to look familiar if you've done Go. Like I said, Fyne uses the same Go paradigms that you would use in all other frameworks. So if you've done Gin or something like that before, this will look familiar, except this allows you to create desktop applications with windows and buttons and labels and all those wonderful things. Standard format printf, that's something we use a lot, right? That's our debug tool of choice, right? And then I've got something called run application, which is just a Go function. And just to show you that this is standard Go, there's nothing special about it. We have that issue where Go is not so great with default values for parameters. This is one of the patterns that gets used to get around that, where we say, I declare a window title and I give it a name. And if you did pass in one, I will use that. But if you didn't, I have a default value. So that's a very, very standard Go thing that gets used a lot. Because for some reason, Go doesn't have default values for parameters. It's ridiculous. But, that's how it is. First thing we need an application, because it's called a desktop application. So we need an application, and Fyne, the library that we're using to do all this, has an application that it defines. We say we want a new one. Then we're going to create our main window. And the main window controls the life cycle of our application. So once that main window comes up, that is what users will see. And if they close that one, we want the whole app to shut down and go away. So that's why it's got its own little special function. Then we're going to create a second window, which does something. And it's just a little distraction for the users, but it's just to show you that you can have multiple windows open at once and you can control all of them from one single application, just like you would expect in a normal desktop application development environment. And then, of course, the last thing we do is, now that we set up our windows, we tell the application, please run. And this is blocking. So you have to do all your setup and things before the time, and then this starts running. Once this runs, of course, you can still interact with windows and with buttons and all that kind of thing, but you need to do your setup before you call application.run. Some of the tutorials are not so clear about that, and then you wonder why stuff doesn't show up. So let's go take a look at create the second window before we dive into the heavy stuff, because this is where the tire hits the road, and it's important to see that this is standard Go, and it's also important to understand how some of this works so we can figure out what we're doing. First thing we do is, now that we have an application that we send in as a parameter, we say, create as a new window, give it this title, and we obtain a handle to that new window. So now we've got the window, we say we want to add some content to it. In this case, we want to add a progress bar, an infinite progress bar. Fyne has got a ton of widgets built into it. You should really go check out their widget list. It's impressive stuff, and you can basically build everything that you want with just the built-in widgets. They do, of course, give you the option to override widgets and build your own custom widgets, which becomes handy if you want to do things like display progress graphs that depend on different streams of information, or you want to have complex dials or things like that. So we give our window a bit of a size, and then we do something where we intercept the close operation on the window. So in this case, we don't want the window to be user closable. So we are intercepting the close operation, and we are giving a function to say, okay, just print a message, but don't actually close, and then we show the window. So just keep in mind, this is how the second window works. So we go back, and then remember we spoke about the main window. So let's take a look at this. So there's a couple of things happening here. I'm just going to run through the function quickly, and then we'll dig into how each part of it works. We're going to make a button, and you can see there's a function that we call to make the button, because there's a couple of steps involved in getting the button working. But just like with our second window, we also create a new window and we give it the window title. And if you remember, the window title from application was what we set here. So the default is main window, but we can pass something in if we want to from the main function. But in this case, we're just sticking with main window. And this is important. We set this as the main window, the master controller. So if this window disappears, we want the whole app to shut down. That includes all threads and all that kind of stuff. And this is what we achieve simply by setting this. So what happens is you can close all the sub windows, not a problem. But if you close this window, it tells everything else, okay, it's time to shut down, and then the whole app will exit. Then we start adding some content. And Fyne has got a whole bunch of layout managers. I chose vertical box. So it will put components in a vertical list, one on the other. And now we start adding widgets. And widgets are basically something called canvas objects. And these objects are specific widgets that render themselves in the render loop. So the first one we use is we just use a basic built-in label, nothing special about it. Then we have the clock button that we created up here, and clock button you'll see is a widget that's of the type button. So we've got a label, we've got a button, then we have a canvas that we put in here, and we have another button. And this button we create everything on the fly, and we give it a click handler, which will create something. We set our main window size. We say we want it centered on the screen, and then we show it. And what does it look like? There we go. I hope everybody can see this. So first thing, here's our main window that we created. There's a little label. There's a button. There's an image that we loaded, and we got that from the logo canvas object that we created there. And then we've got another button at the bottom, and there's the second window that we create. So do you remember that we set up a window, we gave it an infinite progress bar, and we have that up and running. And now let me just get the console in there. If I now click, you'll see that it's feeding back to the console to say, no, that's not happening. You can't close this window. You can move it around. You can resize it. You can do whatever you want with it in that regard, but you can't close this. So this can be nice to have some kind of a ticker function, like let's say you're building a call center app or something that shows, okay, these are the stats for the call center. So many calls are incoming and being handled. So many calls are being dropped, that kind of thing. So the next thing we want to do is we want to take a look at this clocket. And that was created when we created the clock button. So let's go take a look at the clock button. This becomes interesting. We are going to make a button widget, and we're going to pass a pointer or a reference to that button once we've created it. First thing we do is we're going to create a clock window. We're going to assume that the window is hidden at this stage. We're going to add a button. That button is what we see on the main screen. That button has a handler, and it's going to check if the clock window exists. It's going to come here and toggle whether it's hidden or not hidden. If it does not exist, it's first going to create it and then set an unclosed interceptor for it, because we want to know when the user closes this window, because then the whole window needs to be garbage collected. We no longer want it. So how does that work? If we go in and clock it, we get a little clock, and as you can see, it's running. And notice that without me doing anything, I still have all the other threads and things running. So Go is really, really good at these lightweight Go routines that are just running in the background and doing their thing. I can now go and move this around, put it somewhere. And if I click this button, remember we had that toggle, hide and show. So I can go and hide and show the clock, and you'll see it's still there exactly where it was. So I can hide it, but if I kill it, now it's gone. And I notice when I go clock it again, it will recreate the new one in the same old position of the initial one. So if it is existing, it will toggle it on and off. If I close it, then it will create a fresh one. So that whole thing is self-contained, and all I need to do is I just need to call this component, add it, and then it will handle its life cycle all by itself. Next one that we have is this logo that we're loading here, and we have a function for that, create Go logo canvas object. Can you believe it? Very simple. What I do is I go and load the logo image. And this is where if you've done any Go, this is where you're going to go, oh, I understand this code. I know where this is coming from. Typical in Go, we've got a function to open a file on the operating system, and it's going to give us two things. It's going to give us the file and potentially an error. So what are we going to do? Well, before we handle anything, we're going to remember that once we've opened a file, it's probably important to close it. Otherwise, you run into all kinds of open file handle issues and everything. So we're going to defer the function that we pass in here. And defer means call this right at the end when this function is done. Right at the end, the last thing you do is call this code here. And what this is going to do is it takes in the image file and it tries to close it. So this is assuming, and remember, this runs right at the end. So this is assuming that the file opened. And this only runs right at the end. So this can be a little bit of a screen with your mind if you don't understand Go yet. But defer is very powerful. So I can remember that I need to close my file, but I've got a whole bunch of other stuff I need to do. So I'm going to say defer this right until the end. But my open and close are together. So logically, I can see, okay, this is how I open it. I'm going to close it. Okay, that's all good. Now I can continue with the rest. And I can say, if there was an error, then I can say I couldn't find the image or something like that. So you can handle your error in here. If there was no error, you continue and you say, okay, it's a PNG file. I'm going to decode it, get the image data out of it. If there's any error, I'm going to say, oh, there's an error, and I'm going to log it, and I'm going to return the image data. So here we've got Fyne has got a canvas that it draws on, and you're telling the canvas, I want you to create a new image. That's an image in the canvas format that comes from this image format. And then I want you to fill the canvas with this image, and I'm going to return the image. And then we end up with the Go logo up here, a PNG file loaded. So that's pretty handy if you're doing desktop application development, want the company logo in the background or something like that. So we have all of that. And now we've got another one. Remember, we went and said we've got a new button that we wanted to add. And because it's a vertical box, as we add the stuff, the one under the other, and you can see here, we've got the vertical box, we're adding all the components. And there's another one, create another window. And if we go into that, we'll see, okay, there's another window. Actually, I wanted to go to the clock just for interest, to show you something before we dig into that. So this is the clock window. Remember when we clicked here on clock it showed us this little clock, and you'll see that the clock every second it updates. And it doesn't matter what I do with it, whether I hide it, wait a little bit, come back, you'll see that the time is still running in the background. Even, you know, if I kill it, then obviously the thread's going to start again. But let's look at how that works. So once again, the clock runs in its own little window. And we know that because when we say clock it, we get a whole little window. And we can take that window, we can resize it, we can hide it and bring it back. So there's the little clock window. So we create the window and then we say update time. Now what update time does, it goes and gets the current time, formats it, and then set the text of the label that we pass in to be the formatted time. And that label is this one that we create here. So we just create a new empty label with no text in it. Then we update the time, which does this little hard work of going and get the time format to put it in there. We create a new window. We say this is a clock, and we can see there's the window title. We set the content, because this is the only thing that we want on there is this label. So there we can see this label, and you'll see that as we resize this window, it doesn't allow us to go too small, because then we can't see the label anymore. We resize the clock window to be just big enough, and that is now, so we can make it bigger if we want, but we can't go too small. And we center it on the screen. And that is that part where when you create the new one, it will always be centered on the screen. So if I move it around and I just toggle the hiding, you'll see that it remembers where it was. But if I kill it, because there's now no more reference to it, when I create a new one, it's going to pop it in the center. And here we have a Go routine. The Go routines are very lightweight threads. If you've used Kotlin, you know about coroutines and stuff like that. So it's very much the same principle. So this is a very lightweight thread. It's not exactly an OS level thread as you would use in some other languages. This is more a time slice allocation that Go manages on your behalf. And the more Go functions you have, the more native threads it will start up to manage all of these. What I love about this is I don't have to worry about CPU usage or whether I need two main threads, two primary CPU threads or 4 primary CPU threads to be able to run all my routines and stuff. Go handles all of that in the background for me. If I have too many Go routines, it will spin up more native threads to be able to manage all of that. But here, all I'm saying is I want a coroutine that's going to run, and what it's going to do, it's going to range over time, and time is a producer, and it's a channel that I can communicate with. And every time there's a second that has lapsed, I want it to come. I want this coroutine, or this Go routine to come back and trigger the update time method. And remember, we used update time in the beginning to set the current time. And that is now, every second, this Go routine comes back and updates my UI with that. And see how update time simply updates the label, the text on the label. I don't have to worry about syncing and refreshes and all of that kind of stuff. All I'm doing is I'm just saying, update the text of this label, and then Fyne, the framework, goes and does all the hard work on this case in the Mac to say, okay, there's been a UI update and this window needs to refresh. So all of that is handled for me in the background, and I don't need to worry about it. It just happens. So even if you watch me dragging it around, you'll see that the time even changes as I'm dragging it around, which is pretty handy. So then we just show the window and we return a handle to the window. And why do we do that? Because in clock button, what we do is we get, just go there. What we do is we get the clock window. We have that defined, and that clock window, we get a handle back to it. And what we can do with that is we can do a set on closed function here, where we say, when the clock window is closed, I want you to let me know when that event happens, because I'm interested in knowing when it happens, because I have to now forget about this clock window because it's been closed. Then I should no longer try to toggle whether it's hidden or not, because it actually doesn't exist anymore. So next time someone clicks on this button should say, oh, wait a minute, that clock window is actually gone. It doesn't exist. Let me create a new one and then set up everything again. So I can go through the whole cycle of closing it, creating a new one. I can move it around. I can hide it, unhide it. I can close it, and I can come back and create a new one. So that is what also does. And throughout all of this, I am not doing any thread management myself. Go is handling all of that for me. So here in the create clock window, I've kicked off a Go routine that, like we said, will range over time. It will iterate over time, and every second it will come back and update the clock. But I don't do anything with the life cycle of this Go routine. It is tied to this particular window. And when I close this window, that Go routine is also disposed of on my behalf. So here I go and I open a thread, and now there's a thread running, and I don't have to worry when I close here that I have to notify anything or close the thread to do any of that kind of stuff. So that's really, really awesome. And that is standard Go. That is not something that Fyne gives us. That's just basic Go. The very last thing that I want to look at is in the main function, we've got something called create another window. And what create another window does is, believe it or not, it creates another window. So let's go take a look at that. If we click on here, we've got a window that's pulsing between different colors. If you just make this a little bit smaller, I'm just going to move it into that corner, and I'm also going to bring up the clock. And if I put everything here together, what you've got is you've got multiple windows doing their own thing in the background. So this one's just got an infinite bar, progress bar that it's busy with. And we can go and resize things, and notice that even as I'm resizing it, it's still drawing. The clock is still running. This window is still doing its little cycling. And what it's doing is it creates a new window, it creates a canvas, it creates some colors. I say I want a rectangle that will basically fill the whole thing by default. I set the content to be this rectangle, and because there's nothing else, it just fills the whole screen. As you can see here, fills the whole screen. And now I have another Go routine that I created, a lightweight thread. And I've got a little state that says is blue, and then I sleep. And normally in most apps, sleep is a bad idea because sleep blocks everything else. So sleeping would mean that I can't go and drag windows around or things like that because the whole thread is paused. Your main loop is paused. But I'm doing this inside a Go routine, which means that I'm not doing this on the main thread. I'm doing this in a separate thread. And what this does, it runs in an infinite loop, as you can see. And all it does is it waits 1 second. And after 1 second, it says, am I blue? Let me go green. Am I green? Let me go blue. And all of this is happening in the background while all these other threads are running. And as you can see, my UI is not blocked. So this is standard Go. There's nothing special about it. This is just a Go routine that's running in a loop. And every time I change the color, I just call refresh. And what refresh does, it just forces the window to redraw itself because there's no user interaction. It needs a refresh to let it know that, hey, I've changed your state and I want you to update yourself. The other thing is I can now go and close this. And if we go, yeah, we don't get any runtime errors or anything. We don't get any threads that have exploded because, believe it or not, Go handles all the shutdown for us. So let me just open that again. And we can see that, okay, there is a window running. There's another window running. I have all of this at my fingertips, and I can do all these things. And what's lovely about it is the fact that things like this, I get really excited about, where I can offload work onto a background thread that will start running, that will do its thing, and I don't have to manage it. And that is, of course, just standard Go. Just go into the chat. Yes, exactly. Go's concurrency is insane. So I really enjoy it as a programming language. And I was quite impressed with the fact that I can go and create desktop applications with Go as if I know what I'm doing. Sure. So that's basically what I wanted to chat about. I do want to leave some room for questions, because I'm sure there will be some questions. Is there anyone that has a question? Well, Faith, yeah, I just know how to Google. Well, so far, Hercules, I haven't been able to paint myself into a corner. So I reckon that because the Go routines are running in a separate space and your main thread is not locked up, I don't see that's going to be a problem. That being said, I have only done a few things that could potentially lock up, long database access or heavy file reads, but I've never experienced the UI to lock up. I have experienced the window I'm in to kind of become non-responsive for a split second, but that could just be because of my stupidity. But the rest of the app continued to run as if nothing was happening. You just notice that the machine you're on, that the CPU usage climbs a little bit because you're hogging a core instead of, but again, the fact that the Go routines make it so simple and easy to break work down into threads and that gets managed on your behalf is so awesome. Okay. So let me just answer the first one there. Go versus React and TSX. React is easier, quicker, faster, definitely. Better documented. So all of that stuff. The downside is that React runs on Node and you don't have true multi-thread capability, which can be quite an issue. So for me, the two things that stand out to this particular technique is, number one, I have true multi-core capability. If you've got a 16-core machine, like my Ryzen 9 desktop, I can run 16 cores to the max. So you can do incredible amounts of processing because Go gives you that power, right? And what I do is I create a whole bunch of Go routines, and Go then goes and says, okay, this idiot is running 300 Go routines. I'd better use all the cores in this machine. And then you have all of this stuff working. And if you split your work up properly, and it can run in parallel, you have a tremendous amount of work that's running in parallel with the whole machine being utilized. I haven't really had that experience with Node, where I can take one core and I can really make it work hard, but then 90% of my machine is just sitting there and doing nothing. So React is quicker, faster, easier, definitely. What I would say is, if you're just doing something that doesn't really need performance, then go for that. But if you're doing something, and can't say too much about the project, but if you need something that's got multiple data sources coming in and it's got multiple heavy processes running on those data sources and trying to keep track of different things, and response time is very important, then consider Go. Because apart from Fyne, the real core thing here is that you'll be able to do the business logic, and that's where I see Go as winning. So Fyne is a UI toolkit. I've only really used the UI parts of it. It allows you to use native widgets, well, near native widgets, where it tries to use as much of the local user kit or UX kit that it can. I think the main purpose for Fyne is that it makes it easier to use Go to build, I'm hesitant to say cross-platform, but let's say cross-platform desktop applications that will work on the main platforms. So other than Fyne, I haven't really found anything that's this easy to use on all kinds of platforms. There are, you do get Windows bindings, but then it's only a Windows UI that you're building, and that won't work on Mac, for example. Fyne is this really cool toolkit that provides enough for me to build a desktop app. Then, okay, the next one is, oh, the desktop app. You can build a native binary, and you can build that native binary will be a Mac or Linux or Windows binary that's self-contained, that has all the dependencies and everything it needs in there. And that you can then distribute with your normal platform-specific installer tools. So on Windows, you can create a normal installer. On Mac, you can package it any way you want. Create some kind of a native installer. You can zip it up, or you can create exe installers. It's just a binary at the end of the day, and you can even distribute it with like in Windows environments, they distribute it with the administrative tools. They can push the binary down onto someone's desktop, and then they have that. So that works really cool. I've actually seen that happen a few times, where we push the desktop application and it just gets distributed as part of the Windows update and refresh cycle in the company. So one day you don't have the app, next day it's on your desktop, and there you go, it's done and dusted. Then yeah, so Fyne doesn't have an installer library that I'm aware of, but I do know that you can use any standard Windows installer library, for example, to go through that. Oh yeah, parallel work in JavaScript land can be a little bit tricky, and web workers and WASM is awesome, but that's a lot of work. It's a lot of overhead. And I've found that for most cases, and this might be controversial, but if I need to do something, I'll probably do it in Go. If I need to do something that is incredibly important, that it's as fast as possible, as resource conservative as possible, I will go Rust. But the challenge with Rust can be that it can take you quite a while to build stuff in Rust. And then we don't always have the luxury of that amount of time, because you're trying to solve business problems and everything. And then also the other downside is that on a lot of teams, just because I know Rust and I can write Rust doesn't mean anybody else can. And it's, as a language, it's got a few barriers. It's definitely worth learning because it's so performant, but in the corporate space, often it's easier to use Go because it's easier to get people to think in Go. I think the barrier to entry is lower in the Go world. Replacing Go with PHP 8, funny enough, for some use cases, you could do that and you wouldn't notice the difference, to be honest. I'm super impressed with PHP 8 to the point where I think it's awesome, and I think more web projects should consider it. I think a lot of the stuff we do is overkill, and with where PHP 8 has gone, I think it's become a serious contender, even for high performance applications. You can call native code from Go. There are some interfaces for it where you can do that, and a lot of the, like for example, Fyne does do that. It does call some native libraries and stuff to be able to do all the rendering, because there's just amazing OpenGL libraries and things out there. What I've also seen is a lot of people take a lot of C and C++ code and rewrite it in Go, because you get massive performance increases from a productivity perspective if you have the time. So I do think that well-written C and C++ code is more performant, but Go gives you a lot of safety. It gives you easy threading, and all of that, depending on what you're doing, it might be worth your while rewriting stuff in Go. If it's feasible. If it's not, then yeah, you can call native code. You can do that. It becomes a little bit messy. I'm fortunate that I haven't had too much of that to do, but there are really cool wrappers out there for a lot of the more popular C and C++ libraries. Ezra, did you have other questions you wanted? to throw in here? Sorry, man, you broke up there.
No, I said people mentioned a lot of the things that I was going to ask about and mention, but I had to mention PHP as well. Obviously, people throwing hate and laughing at my question.
The thing is, I used to laugh at PHP. I really did, because I thought it was a joke, and it was. And PHP 7 kind of changed things, but PHP 8, man, the thing grew up. It's gotten serious. It's gotten to the point where I can no longer just laugh at people that use PHP. I'm now forced to call them developers. Which is,
I'm gonna give it a try.
hmm?
I'll give it a try, definitely. On your recommendation.
I was impressed. I have to say, none of that global crap and everything, but I mean, well, I see what you mean, Hercules. With server-side rendering and then Next.js and stuff. It is cool, but if you think about how much code exists in PHP today, especially in the WordPress environment, there's thousands of companies that depend on it, and they make millions. So, in their case, a rewrite isn't necessarily going to work for them, because their core skills are PHP. And if you're willing to eat humble pie and start PHP 8 from scratch, like I had to, and you go through the language properly and go through the tutorials and the tools and stuff, and you realize that, wait a minute, this thing has grown up, and it's actually become a real cool language. And you look at Laravel or frameworks like that, it's mind-blowing, the things that you can do in that. It in some aspects, I think it rivals Ruby on Rails for a lot of things. But the one thing, I think the most underappreciated thing about PHP is the total cost of ownership when it comes to servers and stuff. I can get to deploy a PHP app on a 19 Rand a month server, and I can serve 35 concurrent users easily. And depending on the size of your business, that might just be perfect for you. Bob's Plumbing in Bloemfontein doesn't need web scale stuff. Their business needs a way for people to come online and make a booking. And you can do that in PHP. You can run that on a 19 or 20 or 30 Rand a month server, and their total server expense in a year, is what you spend in an hour on AWS. And coming back to Go, this is why I use Go for so much as well, because this tool, I don't think Go is the best programming language out there. I don't think it's the most performant. It's definitely not the sexiest programming language out there. It's kind of lame, kind of basic, kind of, I'm never going to be a cool kid because I use Go. What I am going to be is I'm going to be the guy that delivers business value, solve the business problem, and the business is going to be happy to write me a check at the end of the month. These days, EFT, but you get what I'm saying, is I can solve the business problem. And because I have a tiny little binary that I can deploy in a tiny little Docker image, I can do stuff on AWS Lightsail for $10 a month that you're going to struggle to do with other things for $30 or $40 on an EC2 instance. And I think a lot of companies, especially from a consulting perspective, have realized that, yeah, it's great to build something in the latest and greatest language, and we can use R or whatever, it doesn't matter. But at the end of the day, we also have to look at, what is our runtime expenditure? How much does it cost to run and maintain this stuff? How much does it cost to scale it? how much money are we giving to the cloud providers every month? Because we have to have reserve capacity, and it's difficult to scale things and everything. Whereas simpler languages, and I'm including PHP here, simpler languages like PHP and Go and things like that, it's easier to think about scalability in them because you don't have all that options. It's easier to build something that's going to maximize whatever resources you have. So when you do add resources, you don't have to add a ton to get so much more improvement or performance or something like that. I think looking at this, I don't know, Daniel and Hercules and Craig, will you guys drop us an email to get your JetBrains licenses?
Sorry, Craig and?
So I think Craig and Daniel and Hercules.
Cool. Yeah, just drop us a mail with the title Ewald knows Go.
No, Ewald's lame talk. I think Faith has 11 licenses by now.
Well, gets one every month.
So cool. Awesome. Is there any other questions?
That's probably the end of it.
Cool.
Very nice talk. I think lots of people are there's going to be a peak on PHP 8 Google searches this evening.
PHP 8, and then do yourself a
And
favor.
obviously,
The free Code Camp Go YouTube course. Even if you don't do anything except go through the first hour, just look at it, just listen. If you're a developer and you haven't used Go, just go and listen. Just check it out. It is so cool. There's a couple of things that in the beginning I went, oh Jesus, man, Go sucks. But the moment I started trying it out, I was like, oh, wait a second, this actually makes sense. Like, for example, I just want to go and see here. This, in the beginning, I thought, oh, crap, man, what is all this if error? Because Go doesn't have exceptions. It doesn't do the whole exception thing. So there's no throws and catch and all that kind of stuff in the traditional sense. You deal with errors where and when they happen. And in the beginning, I was like, oh, this is tedious. This is a pain in the ass. It kind of forces you to think about errors and kind of forces you to think about your code. You end up writing cleaner code, because if you don't, you end up writing a lot of code, and that sucks. We all know that sucks. So you end up writing cleaner code so that you can write less code so that your life sucks less. But what I find about this now, I start to think about this kind of thing in other programming languages as well, where I'm thinking, should I handle this error here? Whereas previously I would have just thrown an exception, and caught it somewhere else and dealt with it. But yeah, exactly. It's a lot like Rust's result, but it's easier to think about, it's easier to deal with. And it took me a while to get out of the try catch thing, like you mentioned, Hercules, because I'm used to try catch. I'm from the Java world, man. We try catch everything. But this forced me to not just use try catch and rely on that crutch, but actually deal with stuff as it happens and figure out, okay, what do I want to do at this point? How do I want to handle this and everything? And in the beginning, I disliked Go error handling a lot. And then I started working in teams. And I realized exceptions can be really tricky, especially if you're new to the code base. you can be jumping around like crazy trying to figure out where the heck is this being handled and how's it being handled and what's happening. Whereas with the Go code, as I'm reading through the code, I get to, okay, if there's an error, this is going to happen. So yeah, exactly. Go error handling makes the flow easier to reason about. I love that. I love that because I'm not jumping through 17 different windows to figure out where this code is going and where it's bubbling up to. I can see right here, I can look at it and I go like, oh, on line 53, if there's an error, I'm going to handle it there. So when I'm debugging, when I'm trying to figure out what's going on, I can go and I can say, yay, there, that's where I want to be. That's where I want to work. Josh, you had a question?
Yeah, I just noticed from the code there that when you handle that first error, you don't return or anything. So
No, I
how
don't.
is that intentional?
Yes.
So you
Yes.
still try and decode the PNG even though there was an error, or
Yes.
does it break by itself?
No. In my case, because I know nothing is going to go wrong, I just put some sample code there. But in reality, what should happen here is I should say, okay, I couldn't find the file. Then I should either return a null or I should return some kind of an error. And how that would normally work is I would up here, I would have some kind of a error thing that I would return as well. So I would return a closure with either the image or with an error structure or handler or something like that. But to keep this simple, I just did the naughty and just logged the error. So yes, thanks, Hercules. It's a classic. It's a classic. Yeah, I'll just let you know there was an error and then I'll continue as if there wasn't an error. Well spotted, Josh. So in this case, if something did go wrong, the whole app would just spectacularly explode. It will be messy. I think I did put a disclaimer on the Meetup group that you should just not run this code. Awesome code review, Josh. I'll endorse you on LinkedIn.
To be honest, I was literally just asking because I've never seen Go code before, and I wasn't sure if there was like some implicit return or like.
No, there isn't. So like I said, what should happen up here is I should actually have something like this.
Yeah, that makes sense. So similar to what the image decode is doing and the OS open is doing.
Yeah, it's the exact same thing. And then whoever calls me will say, okay, I get these two values back. If this one is populated, I know something went wrong. If it's not populated, I can assume that the image was found and decoded and stuff like that. So that's on me. Sorry. You Josh, you specifically should go take a look at that free code camp video.
Thanks. I will take a look. I've never looked at Go before. It's on my list. It's just the list is long.
So Go for me is the new Java, if I can put it like that. From an enterprise perspective, if I have to build a bank or something like that's API, I will seriously look at Go as my first option. Because it, like Java, it does almost everything for you. It's got a very rich standard library, but it's also very good at handling threads and stuff. I mean, the Go routines are really cool, where you can kick off 10 different calls at once, and they all go off, do their thing, and then come back, and then you can synchronize them, and we've got channels that they can talk to each other, and the whole works, everything. But from an enterprise perspective, I think Go is really something.
I think Go is just a lot quicker and easier to get started with than Java.
Yes, there's less boilerplate. There's definitely less boilerplate. These days, though, I mean, we smash Kotlin in the Java environment, but even then, This is nice. And what I do love about this, I think the one thing that's often overlooked is the fact that I don't have a runtime environment that I need to worry about. I have a binary that I built that can pop into a Docker image. And I can have a tiny Docker image. You know, and I don't have to have any layers or Graal VM stuff or anything in there. I've got a little binary that just does its thing. And on a lot of projects where I work, you know, especially in the Java world, the build and then deploy to dev cycle is quite long because there's a whole bunch of stuff that needs to happen. And oh, dude, TypeScript is awesome. I love TypeScript.
Yes, but I want to go back to Dart.
Oh yes, yeah, no, Dart is fun. Yeah, so Go binaries are self-contained. There are ways around it. You can build binaries with dynamic link libraries and all that kind of stuff. But the default build for Go is a self-contained binary. And I used to build a whole bunch of the stuff on my Mac for Fedora Linux, which was our deployment server. I just built it on the Mac, created the Docker image on the Mac, and then just uploaded all of it. But the binary wasn't a Mac binary. It was a Linux binary that's cross-compiled on this machine. So I could actually test it in a VM on my machine first before I upload it. But it was the real deal. That was the binary that was going. And because it was self-contained, it was very easy to move it around and all that kind of stuff. Really cool. Yeah, in TypeScript, if you use any, you get fired. That's it. If I see any in the code, then you're looking for a new job, because then you're not using TypeScript. Oh yeah. Kotlin especially, Josh. I agree. Kotlin is such a cool language, but you know that I'm waiting for them to get Kotlin native proper. There's still a lot of no-nos there, but it will get there, and then it will be a serious contender. When you have no more JVM dependency, and Kotlin native will kick ass when it comes to WASM as well. I haven't watched the new Dart stuff. I need to do that. I did see that Flutter is getting quite serious. Cool. So are there no more questions? Ezra, is that you?
Yes. No, can you?
You disappear.
No, I said I don't. Like lots of interest.
Yeah, there's so many cool things happening. There's really cool things happening. So it's an exciting time to be in the tech world.
Yeah.
Awesome, folks. Thank you so much for attending tonight. Really appreciate it. Peeps must email us for the JetBrains licenses. Thanks, mate. Everything's fine.
Please remember to email us.
Sorry, Ezra.
I said, please remember to email us because we really want to give those licenses away.
Yes. We do email us. We have some cool licenses, and I love IntelliJ. I like Visual Studio Code, but I love IntelliJ. So, all right, awesome, peeps. Thank you so much. Really, thank you for attending. We appreciate it. We would be nowhere without the community. So, thank you for showing up. Ezra, you want to stop our